Okay, first contextual problem. We have a graph representing the changes in temperature over a 4-hour period. So this is what it looked like when it got graphed. Okay, discuss what's happening and part of the domain that doesn't really make sense with real life. Okay, so if this is talking about time and temperature, we would more than likely have our time on the x and our temperature on the y-axis. Okay, so this part of my graph doesn't really make sense. Why?
You can't have negative
Time negative, that doesn't make sense. Okay, so basically you're saying this graph would start exactly there. Okay, so then when we start, okay, we're kind of cold and then it warms up, then the temperature goes down, and then it warms up, and then the temperature goes down. Okay, does this make sense that the temperature is just going to go down, 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 down? Like, can we have a negative 3,000 degree? Probably not, right? So I don't know where the exact point would be, but eventually just doesn't really make sense anymore. Okay, make an equation. Okay, so let's do some variables. I don't like T and T for time and temperature. That doesn't really work. What do we want? Time equals what and temp equals what? What do we want for letters here?
E and P.
E and P.
The last letter.
Oh, the last letter. Gotcha. I'm like, where did you randomly pick those? E and P. So temperature P equals some kind of A value. I don't really know the coefficient right now. Okay, the first intercept is 1. So this will be E minus 1. What physically is happening at that intercept? Bouncing, so I need a squared. Then the next intercept is at 2, so the factor will be E minus 2. And then the next intercept is 3, so E minus 3. Okay, now I'm going to plug in a point so that I can solve for A. So I'm going to plug in the coordinate 0, negative 12. So negative 12 equals A. 0 minus 1 squared. 0 minus 2. And 0 minus 3. Wait, what is that all going to make right there?
6.
Positive 6. Positive 6, so A is negative 2. Does that make sense that A is negative when you look at it right away? Negative slope? Okay, so P equals negative 2, E minus 1 squared, E minus 2, E minus 3. That is my equation. Okay, question 3, or C, says find the temperature after 4 hours. So what do I do if I want to go to 4 hours? I will do what mathematically? I'm going to plug in 4. So what is the temperature when I plug in the value 4? I got negative 36 degrees. Okay, good? Just plugging in. The last question says estimate the max temperature. So where do you physically think the max temperature would occur? In this zone, right? Somewhere between the second and the third hour. Okay? Does that make sense physically? Somewhere between the second and the third hour. So this is an estimating question. So I'm just going to use 2.5. I'm just going to use the midpoint. It's probably not exactly the midpoint, but that's what I'm going to use because it's an estimate. So I'm going to use 2.5 hours, and then I do the same thing and I plug in. If somebody wants to go crazy and get it more exact, you can plug in some other random values if you really want, like a 2.4, a 2.3, a 2.6. But it's an estimate, so that's good. Okay, volume. Okay, so I have a piece of paper that is 6 by 6 centimeters. Okay, what I'm going to do is I'm going to cut a little square off of each corner. Okay, I don't know what I'm cutting, but it's going to be a square. Okay, that's a square. And then I'm going to repeat that square in each corner. Okay, so now this is my shape. All right, so if this side started as 6 centimeters, what is the space between here and here? Okay, do I know how much I cut off? No. So I'm going to say I cut off X amount, and I cut off another X amount. So if the whole thing started as 6, what is the space right there that's left? The whole side was 6, and then I cut off X, and I cut off X. How do you represent that with math? 6 minus 2x. Yep. Does that make sense? I was 6, and then I took away x and another x. Okay. Same on this side. If we started with 6, we cut off an x there and an x there. Okay, so there's my 6 by 6, and I cut off little corners that were x by x. Okay, now what I'm going to do is I'm going to fold up the sides. Maybe you've done this before. And now I have a box. Okay? Who's good at drawing three-dimensional here? Ooh, look at that, three-dimensional. There's my box. So this is 6 minus 2x wide. This is 6 minus 2x wide. And what is the height of this box? Because I folded that up. Remember, I cut the x off, so when I fold it, it's going to be x. Okay, how do you find volumes of a box? What's the generic formula?
Height times length.
The volume would be the length times the width times the height, which is 6 minus 2x, 6 minus 2x times x. Okay, tell me where to put the x-intercepts of this to do a graph. What value do I need for x to make this bracket worth 0? Backwards thinking. 6 subtract 2 times 3. Are we in agreement but that the second one is also 3? So what's going to physically happen if those were both the same x-intercept? There's going to be a bounce, right? Because that's also, right? You squared that, really? There's going to be a bounce there. And what's the x-intercept of this bracket? 0. What kind of shape or letter does it make when you graph this? N shape. It's cubic. Volume is cubed, right? It's cubic. So you're going to do an N shape. Make sure you bounce at 3. Okay? Did you notice that I didn't do my y-intercept? Because it's 0, right? It's already on there. Okay, so this was the number that we cut, and then this would be the volume. That's what's going on. X is the amount that we cut, and then it results in the volume. Okay, some stuff on this doesn't make sense on this graph. Why doesn't it make sense?
You can't have negative volume.
We can't have negative volume. So that part of the graph doesn't make sense. What else?
You can't have infinite volume either.
You can't have this, but why?
You can't cut infinite amount of material.
You can't cut infinite amount of material. What is the most I could cut off? 3. I can't cut off exactly 3. I could cut off like 2.99. So you can't cut more off than what you would have, right? I also can't be on this dot exactly because I can't be 3. What happens if you're 3? You're 6 and you cut 3, 3. What happened to your length? It's gone. You can't have 0 length. And also, you can't be on that dot, right? Because you can't have 0 height. Or now you still just have a flat piece of paper. So what is the domain? Anything from 0 to 3, but what do I need to know? Round brackets. So I can cut off 0.1, that's fine. I can cut off 2.99, that's fine. Estimate is our last question. What is the max volume? So you're estimating it. So I don't know where exactly it occurs, but what would be a good x value to use? 1.5. Okay? It's not going to be the max, but you don't know how to do that until you hit calculus and stuff. We're going to graph these exactly with maxes and mins. Volume equals 6 minus 2x squared times that x. Okay, so I just use the equation I made. Okay, it's an approximate. Okay, please make sure you put a star and note can't have lengths, widths, or heights of 0 or negative, right? None of that makes sense. So on that problem, just remember when you're doing the equations, graphing it, you can never have one of your dimensions that's 0 or negative.